We human beings love to solve puzzles. Be it a chess, a crossword puzzle, a colorful Rubik's Cube, or a Sudoku. We really love it. Does an artificial intelligence loves to solve these puzzles too? Well, that may be too early to call, but we can certainly train one of them to solve these puzzles. And that is what we are going to do with thousands of other participants at AICrowd AI for Good Blitz competition. One of the challenges in the competition is to train an artificial intelligence to solve one of the most interesting puzzles of the world, the Sudoku. What is Sudoku? Sudoku is a puzzle game loved throughout the world. Starting a humble opening in the US, Sudoku initially became popular in Japan and later it took the world by storm. A Sudoku puzzle contains a 9x9 grid. This 9x9 grid can be further divided into 9 smaller 3x3 mini-grids. The aim of the game is to place a number from 1 to 9 into each of the cells such that each number must exactly appear once in each row and must exactly appear once in each column. Additionally, each mini-grid must contain all the numbers 1 through 9. This is one valid Sudoku grid. This is another valid Sudoku grid. And these are many others valid Sudoku grids. In fact, there are 6.671 times 10 to the power 21 valid Sudoku grids. And it looks like we are not running out of Sudoku puzzles very soon. In this competition, we are given thousands of training images of Sudoku puzzles like these. The images may be of different colors, and these images may be rotated by an angle. For each of the training images, we are also given with solution set for each puzzles, which looks like this. The first task seems to form a Sudoku puzzle from images by detecting numbers and blank lines. Next, using these Sudoku puzzles, we have to develop a Sudoku solving model. The Sudoku solving model can be a neural network, it can be a constraint programming, or it can be a backtracking, or it can be anything valid. After that, we will use the Sudoku solving model to find the solution for all the puzzles in the test set. Then, we create a submission file with ID and solution as header and submit our prediction of all the test sets to the competitions. During evaluation, our accuracy will be used to test the efficiency of the model. A solution for a puzzle will be considered correct only if all the 81 values are matched. That is, there will be no any partial marking. This is one of the approaches I'm taking to solve the Sudoku solver challenge. At first, let's import all the necessary packages. Next, we have defined a couple of utility functions. Many of them do pre-processing tasks like applying threshold, cropping the images, rotating the images, centering the text, and so on. In this approach, I'm going to use a backtracking algorithm to solve this Sudoku. Essentially, what it does is it takes an unsolved Sudoku while solving, whenever it finds an empty cells, it tries to fill with different numbers from 1 to 9. And while inserting a new number, it checks whether it validates the Sudoku rules or not. If the new Sudoku formed doesn't comply with the Sudoku's rules, then the new insertion is not considered. Let's see the original image here. As you can see, the original image is rotated by a certain angle. Next, we will crop only these Sudoku puzzles. After that, we are going to divide is images into 81 different cells, so we will get 81 new images, and in every portion where there are some black digits like 6 to 5 to 7, we are going to use a neural network to predict the digit. And after that we will form a valid Sudoku board which will look like this. As you can see, this model is not able to predict every numbers, but the advantage of using a backtracking algorithm is that it will be able to find out this missing value 1, 2. Let's use the backtracking algorithm to solve this Sudoku board. After using the backtracking algorithm, we have formed a valid Sudoku solution. The main takeaway from this is that even though our model was not able to predict certain digits in the board, our backtracking algorithm was able to find out it itself. And another thing is this cropping and rotating portion mostly work, but when the images are rotated by a slightly different angle, it tends to fail too. So an improvement on this approach would be to make the rotation process more robust and so on.